Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. I am so excited to have you all here with me. And this is literally one of my favorite things to do during the week. So I just love spending an hour with you, just going over some math problems that might be giving you trouble as you are prepping for your exam. Like Dr. A said, I'm Amy Sink. I'm one of the math specialists here at the Learning Liaisons. And our job here is to just help you feel more confident and more competent in the math skills that you are prepping for on. That's why we do these Wednesday night sessions. We have a lot more to offer on our website, boot camps and practice tests and all of that. But Wednesday nights are just chill. Like bring your popcorn, bring your snack, bring your drink, whatever it is. Tonight, mine is water. And just hang out while we do math problems together. Before I get started, I always like to do a get to know you question because it makes it feel less like we're sitting here in front of a computer screen and more like we're hanging out in someone's living room drinking hot chocolate. So doing math problems. So fun fact, my mom used to do like math Sundays. She was a math teacher for years, and we would have like 20 to 30 high school kids in my dining room, all literally doing math problems. Like that's why they were there. And my dad would cook like a big meal and feed them. It was so fun. I loved it. Anyways, that's where I get it from. That's why we're all here tonight. Before we get started, let me know in the comment box where you're from, what test are you prepping for, and do you like the cold weather or not? Where are you from? What test are you prepping for? And do you like the cold weather or not? I am from Florida, Central Florida specifically, and we had a huge cold front come through. And it was, the high yesterday was like 55 and the high today was like 64. So it wasn't as hot today or cold today. But the lows were in like the low 40s. And I I live for those days. Like, I love the cold. I absolutely love it. I spend as much time as I can outside. Like, I love it. And so many Floridians do not love it. They're like, if it gets below 60, I'm going to Miami. Like, I am not dealing with that. So, where are you from? What test are you prepping for? And do you like the cold weather? Like, legitimately like it? Now, I have lived in North Carolina. I know what it's like to have snow. I know what it's like to shovel snow. Like, I get it all, but I still live for it. Those cold days, scarves and jackets. I love it. Boots. So where are you from? What test are you prepping for? And do you like the cold or not? That said, let's go ahead and get started with our first problem. Hey, Chris, it is good to see you. Cold weather as long as it doesn't snow. Yes, I love the snow, but I don't know if I would want to live in like thick snow all the time. I don't think I would want to live there. TExES 7 through 12 math, same. Yes, the cold, no ice, no snow. Love it. Absolutely. Ice is scary to drive in. I will tell you, we were in Canada one time skiing and my husband was driving and it got real close at one point. We skidded on the ice. Hey, Ramona, South Carolina, Praxis, high school math. We've got quite a few like middle school and high school math people, and you don't like cold weather. Listen, that's okay. I was talking to my maintenance guy today, and he didn't like the cold weather either. So that is okay. And I actually have quite a few. Like, I feel like normally it's like a good balance for like elementary, middle, and high. And I feel like I have a few more like middle and high school problems than I normally do. And I apologize. I've been dealing with this like weird cough for like 2 weeks. Like literally ever since the last time we were here, because we weren't here last week for Thanksgiving. All right. Let's begin with our first problem. Which of the following satisfies the inequality below and makes it true? Select all that apply. Negative 4x plus 13 is less than 28 minus x. All right. So we've got a few answers that we see there. Which of the following satisfies the inequality below and makes it true? Select all that apply. So how do we solve this? We solve this just like we would any equation, but then we really have to look at what we have left to figure it out. So, and that is actually not the problem that I meant to do. Well, we're going to roll with it. All right. So I am going to add x to both sides. Now, if you added 4x to both sides, would you get the same answer? Yes. And I'm actually going to show that to you side by side. So if I was taking this test, obviously I'm not going to solve the problem two separate ways. However, I want you to see that we can solve this problem two separate ways and get the same answer because some people are going to solve it differently than others. So I'm going to add x to both sides. Nope. On this one, I'm going to add 5x to both sides. Sorry, I'm doing the opposite of the other side. Goodness, third time's the charm. We're adding 4x to both sides to cancel it out over here. And I'm adding x to both sides to cancel it out over here. So I have negative 4x plus x gives me negative 3x plus 13 is less than 28. I'm going to continue finishing solving this left side of the equation, and then I'll do the right side just so we don't get confused. I'm going to subtract 13 from both sides, and I'm going to use my calculator. And I'm left with negative 3x is less than 15. Now I'm going to divide both sides by negative 3. And I get x is less than negative 5. If x is less than negative 5, what does that look like on a number line? Even though this didn't ask us for a number line, so often they will ask you for a number line. So what is that going to look like on a number line? If I have a number line and I have negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. X is less than negative 5. That means I have an open circle on the negative 5. Why is it an open circle and not a closed circle? Because an open circle is for greater than or less than, and a closed circle is for greater than or to or less than or equal to. Because I'm including that number if it's an open circle or a closed circle, and I'm not including that number if it's an open circle. So that equals means that I'm closing that circle in. And this says x is smaller than negative 5. So my arrow is going to go this way because x is going to be anything smaller than negative 5. Now, how can I make sure that I did that correctly? Plug in any number that falls under the arrow. So I'm going to plug in negative 6. Is negative 6 less than negative 5? Yes, it satisfies it, so I know I did it correctly. So now I'm going to choose any of these numbers that are less than negative 5, which is only the letter A. Any questions about that problem? Now, let's solve it the other way, just to prove that you can do it both ways. So I'm left with 13 is less than 28 plus 3x, because 4x minus x is 3x. Now I can do one of two things. I can subtract the 3 over, or I can subtract the 28 over. So I have 3x is less than 13 minus 28, which is negative 15. Oh my goodness. You are absolutely right. I cannot believe that I totally missed that. Thank you. So the answer is actually not this and not this. I will get there. And I'm going to show you that I'm about to get the wrong answer, or a different answer. Divide both sides by 3. And I get negative 5 is less than x, which is not the same answer that I got over here. The alligator is eating the x in this situation. The alligator is eating the negative 5 in this situation. These are not the same. Why? Because I totally forgot to flip the inequality. Y'all, when you multiply or divide by a negative number, you have to flip the inequality. So because right here, I divided both sides by negative 3, that symbol right there has to flip. And x is actually greater than negative 5, which means it includes anything over here, which means I actually have 4 answers. Thank you so much for correcting me and realizing that. I would have realized it after I did this because I had 2 different answers, but I appreciate you noticing that. So when you multiply or divide by a negative in an inequality, you must flip the sign. That was an excellent catch. Proof that we all make errors. All right, let's go ahead and move on to problem number 2. Which of the following tables represents an exponential equation? So, in order to solve this, we have to know the behaviors of linear, quadratic, absolute value, like all of those types of equations. So, what I'm actually going to do is I am going to create a parent function page. So, parent functions. If you don't know parent functions and you are taking a middle school or a high school exam, you are going to struggle. You have to know parent functions. So the parent function is just the OG function before you start moving it around or translating it or anything like that. So we have y equals x, which is a straight line that goes through the origin. We have y equals x squared, which is a parabola centered around the origin. We have y equals the absolute value of x, which is an absolute value graph centered around the origin, which is a symmetrical V. We have y equals x cubed, which is a cubic function centered around the origin, and sometimes they can look like this too. We have y equals 3 to the x power, which is an exponential function that looks something like this. And those are really the main ones that we would need to know. I mean, there's always other graphs like rational graphs and stuff like that, but I would say that those are the main ones that you would need to know. So by knowing that, we also have to understand some basic characteristics. So when we look at a line, everything is increasing at the same rate because it has the same slope. Whereas when I look at a parabola, it's not going to increase. It kind of jets up, but it is symmetrical. So whatever I have over here, I have over here. Now, that's not the case if it's not centered around the origin, but what I do know is that it's like positive, positive, or negative, negative. It doesn't go from the negatives into the positives, right? Now, it could, if it looks something like this, it would be negative, positive, negative, but you're going to see that transition where with a line, you're not going to. You're going to see that same transition with a absolute value graph, but it's going to increase at the same rate because an absolute value graph is two straight linear equations put together that meet at a vertex. A cubic function has the potential to change direction 3 times, but you're going to start low and high. And an exponential function, you are going to increase exponentially. You're not going to increase at a steady rate. So knowing literally the world's cliff notiest version of parent functions, now let's go back and look at our tables. Which of the following tables represents an exponential equation? So when I look at number 1, I'm increasing by the same amount in my x's, -1, 0, 1, 2. When I look at my letter B, I'm going -1, 0, 1, -1. So I'm repeating an x. That definitely doesn't sound like an exponential equation. -1, 0, 1, 2, -1, 0, 1, 2. But now I need to look at what my y values are doing. 2, 4, 8, 16. Are those increasing by the same amount every time? Well, you might say, yeah, they are. They're multiplying by 2 every time. You're right. But that means that when I look at a graph, -1 up 2, over 0 up 4, over 1 up 8, over 2 up 16. That is increasing like a skyrocket, isn't it? Whereas C, we're going 2, 0, 2, 4. That's an interesting pattern. -1, 2, 0, 0, 1, 2. So this could be an absolute value, or it could be a parabola. We're not sure, and we really don't need to know. I mean, I know it's absolute value just because of this relationship right here. That slope is the same all the way across, but it doesn't matter because it's not exponential. And here we're increasing by the same amount. And 2, 4, 6, 8, we are increasing by the same amount as well. We're adding 2 to each one, which means it has the same slope. So therefore, our answer is going to be that first table of values. And I know my iPad just disconnected. If you've never been here with us, welcome to the math session where my iPad disconnects every once in a while. And I apologize that I look like I'm in a spooky movie. My computer, listen, the iPad disconnects. The computer's a disaster. I'm buying a new computer today. It literally decided to, like, if you could see my screen, it's literally like stripes and it looks like a horror movie because it just flashes and then shuts off and then flashes and then shuts off. So I'm not sure if you can tell in the streaming other than the fact that my face gets bright and then it stops and then it gets bright and then it stops. So I don't know if it's super noticeable or not, but it's very noticeable for me. All right, let's reconnect my iPad and keep going. While we're waiting for my iPad to reconnect, if there is anything that you want to see me go over in the upcoming weeks, please, please, please don't hesitate to ask. I always have like a next week, 6, 7, 6. I always have a next week slide. So I will start that right now. And if there's concepts that you are struggling with as you are preparing and studying for your exam, let me know in the comment box, and I'm happy to include those in the upcoming weeks. It makes it easier for me to prepare, quite frankly, but it also makes it better for you because I'm going over stuff that you need me to go over. So it's better for everybody. Oh, gosh. All right, I'm going to get a cough drop while we read the next problem. Let's go ahead and read problem number 3. Amaris wants to use an XY table to create a linear equation. Which of the following equations represents the linear equation as represented by the table below? All right, y'all. You're going to have to bear with me as I am chewing on this cough drop because I don't want to lose my voice. So, Amaris wants to use an XY table to create a linear equation. Which of the following equations represents as represented by the table below? So, when we have a linear equation, we have 2 versions of a linear, well, we really have 3. We have standard form, which is AX plus BY equals C. We have slope-intercept form, which is Y equals MX plus B, where M is your slope and B is your y-intercept. And we have point slope form, which is y minus y1 equals m times x minus x1, where you have your slope and then you have a point, right? So that said, I either need a slope and an intercept or I need a slope and a point. What commonality are you seeing here? We definitely need a slope no matter what. How do I find slope? Slope is rise over run, which if I don't have a graph is y minus y over x minus x. Now, some of you have seen that written y2 minus y1 equals x2 minus x1. Why the 2's and the 1's? All they're trying to show you is that whatever point you start with on the top, you have to start with on the bottom. But those 2's and 1's don't matter. So don't junk up your memory with all that extra stuff. Just subtract your y's, subtract your x's, and start with the same thing, right? So I'm going to pick 2 points that I can do for my slope. So I'm going to pick these 2 points. I usually pick 2 points in the middle or 2 points at the end because sometimes test writers are tricky, and they will write an equation that has the same slope as the top 2 points, but then it'll be like a different slope. So I always pick the middle 2 points or the last 2 points. And my iPad just disconnected again, so we're just going to read it and keep on moving. So I'm going to look for my y's, I'm going to look for my x's, and I'm going to subtract. So I have, I'm just waiting. It's like the dreidel song. Waiting, I made it out of clay. Okay, share, present. Run Fanny, is that how you say your YouTube profile name? I see limits and calculus. Absolutely. I will add that to my list. Limits and calculus. When I was in calculus like years ago, I remember this video and it had a car and it explained limits perfectly. So I'm going to try to find that and I'll try to like replicate it on a Wednesday night. All right. So here's my y values. Here's my x values. So I'm going to do -3 minus -1 over, because I started with this one, I have to start with this one. 1 minus -2. -3 minus -1 turns into a positive. So we're going to do it this way. My iPad and my computer will not win tonight. I will not let them. So we're just going to go like this because I will not let them win tonight. All right. -1, -3 plus 1 equals, -3 plus 1 is -2 over 1 plus 2, negative and a negative, 3. So my slope is going to be -2 over 3. Well, unfortunately for us over here, this right here is standard form. That's not helpful because it doesn't give us any information. Standard form is ridiculous, in my opinion. It doesn't give you any valuable information. And I can't see my intercept very clearly in this table of values. Could I figure it out? Sure, but I really don't want to. I have a point slope form that I can use. So y minus y1 and x1. I'm literally going to pick any point here. It does not matter which point you pick. You're going to get the same answer. So I'm going to look for a point that I feel like is going to be pretty easy to use. I'm going to pick -5 and 1. So y minus y1 equals m times x minus x1 is -5. So this becomes a big fat plus sign. Now I just need to put it into standard form. So I'm going to distribute my -2 over 3 all the way through. Ugh. Y'all, this cough is going to kill me. I'm going to distribute it. I'm going to make this smaller and carry it up here so that I can continue working. So I have y minus 1 equals -2/3 x plus -10/3, because I just multiplied the 5 over 1 times the -2 over 3. If you're not sure how I did that, please let me know in the comment box, and I will absolutely go over multiplying fractions on another day. Now, this is where it gets tricky, because now I have to convert my whole number into a fraction with a denominator of 3, or I need to multiply the whole thing by a value of 3 to get rid of the fractions. I'm personally going to multiply this entire thing by a value of 3. Why? Because in standard form, I can't have a fraction for my first value, which has an x attached to it, and the x has a fraction attached to it. So if I multiply everything by 3, it'll cancel these two out. So I'm left with 3y minus 1 equals 3 times negative 2 over 3 is negative 2x. 3 times 3 over 1 and negative 10 over 3, those 3's cancel out, and I'm left with minus 10. Now, I can see which answer it's going to be without finishing this problem. There's only 2 answers with a 3y, and there's nothing else in this problem that's going to combine with that 3y. And then when I look at the x, this is a negative 2x, but to get it on the side with the 3y, it's going to be a plus 2x. So I know my answer is going to be B. But let's go ahead and finish it off. Add the 2x to both sides. And then add the 1 to both sides. So I have 2x plus 3y equals negative 10 plus 1 is 9. Uh-oh. Let me look at that work. I am having such a hard time being upside down. So let me look at that. 3y plus 1, 3y negative 3. Negative 2x minus 10 over 3. I'm going to have to look at this one later because now I'm like all sorts of confused. But that's how you would do that problem. Stephanie, you are so welcome. Yes, Chris, this iPad is just not wanting to cooperate. Let's go ahead and do this problem. This problem, I am so excited about this problem. This is such a fun problem. And I was like, oh my God, they're going to love this problem. Okay, maybe you're not going to love it, but I love it. So we're going to do it. And I'm going to try to connect my iPad one time because it's going to be really hard for me to do this problem if we are not connected because it's going to be hard to do upside down. So let's all cross our fingers and toes that the iPad decides to stay connected this time. It's connecting, it's connecting, it's connecting. All right, it's a geometry problem, which is a problem that a lot of people struggle with. A lot of people always tell me, can you do more geometry? Can you do more geometry? So here we are. We're going to do a little bit of geometry right now. All right, present. Share screen. All right. A circle inside another circle is shown below. The radius of the larger circle is 10. What is the area of the shaded region? And that part got cut off, so that says 60 degrees. What is the area of the shaded region? All right. So, circle inside another circle. In order for me to figure out, yes, Ramona, you're absolutely right. The problem is I got 9 for letter C, and the problem is showing -7, and I don't know why, because I plugged in this point earlier, but it shouldn't matter what point you plugged in, so I just need to work through it and figure out where my error was. But yes, you're absolutely right. B is the only one with a -2/3 slope. So it's really the only option. So really, it doesn't matter if I computed wrong. That's the only possible choice. So that's a really good test taking strategy, actually, is that we shouldn't stress about like where our mistake is, because sometimes we do make mistakes that we can't find. But if we're confident that that's the only one with the correct slope, which we know that that was the slope, then we can move forward and confidently know that that's our answer. Okay. Circle inside another circle is shown. The radius of the larger circle is 10. So I know that this value right here is 10. And what they tell us is that this segment and this segment are the same size, which means this is 5 and this is 5. What does that tell us? What does that tell us? That tells us that the radius of the smaller circle is 5. Because remember, radius is the distance from the center to the outside. And so I know that from here to here is 5. So my radius of my smaller circle is 5. How am I going to figure out what the area of that shaded region is? I'm going to have to do some sort of like big minus small, right? So I need to find the area of the entire big circle. I at least need to start there. And then I really need to figure out what sector this piece is. And then I need to subtract out this section right here. So we've got like 3 different steps. Find the area of the big circle, find the area of just that sector, and then subtract out that sector of the smaller circle. So the area of the big circle is going to be pi r squared is your formula, where r is your radius. So area equals pi times your radius is 10. They told us that, which is 100 pi, because 10 times 10 is 100. Now, I am going to leave it in terms of pi, because when I look at my answer choices, all of my answer choices have the value of pi included. And so I'm not going to estimate off pi to be approximately 3.14. I don't need to do that this time because all of my answer choices have a pi included in it. Now I need to figure out what section what section is that pink section? That's where this information down here becomes extremely handy. That tells me that this section has a value of 60 degrees. What do I know about a straight line? Because if that's 60 degrees, this angle is 60 degrees as well. And what do I know about a straight line? It's 180, which means that this section right here is 180 minus 60, which is 120, right? Well, what fraction of a circle is that? How do I find a fraction of a section? Part over whole. So if I do 120 out of 360, I have my part, I have my whole. This is for everybody, even though this technically isn't an elementary school problem. Finding a part of a whole is finding the fractional piece of that, which equals 2/3. I'm going to cross-check that. Give me 1 second. I'm going to cross-check 120 divided by 360. No, it's not 2/3. It's 1/3. I'm sorry. It's 2/6, not 2/3. So That said, I can now divide my 100 pi by 3. And now I have this section right here. Because if we imagine there's another third and there's the other third. And this 60 is what told us that. Now what do I need to do? Now I need to subtract out this section right here. I need to erase it, which is what? That section right there is 1/3 of the smaller. So now if I find the area of the smaller circle, pi r squared, pi times 5 squared, 25 pi. That's the whole circle. Divide it by 3. That's the part of the circle that I'm trying to delete. Take that whole piece, subtract the smaller piece. What's 100 minus 25? 75 pi over 3. Which is not even an answer choice because I was rushing when I did this. 75 pi over 3. We're on the struggle bus today. E is our answer choice. I'm confident of that because I have it right here too. All right, questions about that? I'll fix that slide today so that I don't make that mistake again. I am going to add limits and calculus to my next week. If you have anything else that you want me to go over next week, calculus, let me know in the comment box and I'll absolutely add it. We still have time for 1 or 2 more problems, so I'm not done. But if you have anything else that you want to see me go over next week, drop it in the comment box and I will absolutely add that in. And I am looking at a calendar. We should be good for a couple weeks before the holidays start back up. We will absolutely be meeting this week and next week, and then we'll probably take a couple weeks off for the holidays. All right, let's go on into another problem. Let's do some quadratic work. This is fun. All right, I love quadratic work. A ball is shot from a cannon into the air with an upward velocity of 30 feet per second. The equation that gives the height of the ball at any given time is h of t equals -16 t squared plus 30t plus, plus 8.5. What is the value of the y-intercept and what does it represent? All right, y'all. Whenever it asks for the value of a certain key element, that's what these are called, key element of the graph, I'm going to graph it. So I'm going to do a really quick sketch. This is what I like to call a baby graph. It's a quick sketch that's not necessarily accurate, but it allows me to see what's going on. So what I know is that I have an upside down parabola that is not centered around the origin because otherwise it wouldn't have all this extra stuff added onto it, okay? And having an upside down parabola centered around the origin, I have a y-intercept, I have an x-intercept, I have a maximum, not a minimum, and the maximum happens at the vertex. I have an x-intercept. I'm going to label these for us. I have a y-intercept. Now, if I was taking the test, this is all I would have drawn. I wouldn't have labeled all of that. I would have just thought through it. But I'm labeling it for us because we're all here to learn. So I'm absolutely going to go a couple steps further than I normally would. Now, what is the value of the y-intercept? Well, what do I know about all y-intercepts? They have a 0 for the x, and then they have a y value. What do I know about all x-intercepts? They have a 0 for y, and they have an x value. So if I'm trying to find my y-intercept, I'm going to plug in 0 for x or for t, which is really serving as my x, and I'm going to get a value. So negative 16 times 0 squared plus 30 times 0 plus 8.5. What is anything times 0? 0. What is anything times 0? 0. So my y-intercept is 8.5, which immediately gets rid of a and b. 16 is not my y-intercept. Now, do you have to know what it represents to be able to answer this question? Nope. Because only one of these is the y-intercept. Which one of those is going to be the accurate answer for the y-intercept? Go back to what we just talked about. 0 for x. D. Now, let's say there were multiples of those. 0, 8.5, 0, 8.5, 0, 8.5, and you had to discern that. What did you just plug in for time? What did you just plug in for time? You just said t equals 0. You just put in 0 for time, which means no time has passed by yet. And I just threw my pen across the room. That means no time has passed by yet. It's not that the ball went up and the ball went down and we're on the ground. Time literally has not started. So what is 8.5? The height of the ball before the cannon even shoots it. So either this cannon is really big, or it's sitting on top of a building or a fort. It's the height of that ball before the cannon goes pew. What does the maximum represent? That's going to be the maximum height of the ball after however many seconds. And what does our x-intercept represent? Because remember, x is a value, comma, 0. So in this situation, a value is going to be t, because t is your x, and 0 is going to be your y, which is h. So what is that value if the height is 0? The amount of time it takes that ball to go up and come back down and hit the ground. Now, none of that was part of this problem, but I wanted to talk through it with you because it's important. Any questions about this problem? All right, let's continue to talk about this problem and then we'll be all done for today. Still the same problem. A ball is still shot into the air, same equation. They ask for the maximum height the ball hits after how many seconds? Y'all, it's not always going to be this easy, so don't think it is. But in this situation, maximum height is found by doing finding my vertex. How do I find my vertex? I find the x value of my vertex by doing negative b over 2a, where in h of t, I have a t plus b t plus c. So this is my a, this is my b, and this is my c. So x equals negative b divided by 2a. Negative b divided by 2a. Negative divided by a negative is a positive. And when I divide those out, I get 0.9375 equals x, which is also t. So what does that mean? That my answer is D, because it's the only one with the time at 0.9375. Now, again, if we had multiple answers with 0.9375, what would we do with that information to get this number right here? Plug it in. So I'm going to plug it back in because t is time, so 0.9375 squared plus 30 times 0.9375 plus 8.5. And I can assure you that when you solve that, you're going to get 22.56. All right. I guess the iPad didn't like being threatened because I said I'm going to give it one more chance. And if it doesn't cooperate, then we're going to just stop and do it the old school way. So I guess the iPad didn't like all of that nasty, that threatening conversation. Let me know in the comments what you want to see from me next week. I am going to turn it back over to Dr. A for the night. We will be back here next week, same time, same place. But like I said, let me know in the comment box what you want to see in the upcoming weeks. I hope that you guys have an amazing week. I'll hang out for a few more minutes while I monitor the comment box and see what else you put in there for me to add to this list. And otherwise, have an amazing week, and I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.